So next generation robotics can be characterized by intelligent machines that are either faster, more accurate, more reliable. They have autonomy and often connectivity to other systems like on the cloud. And that allows them to be used in a wider variety of use cases than conventional robotics. Whenever we deploy something in conventional robotics, we try to constrain its environment. We try to minimize any variation as much as we can. Example being parts coming in on a conveyor, one at a time, all orientated in the same direction. It makes it easier for the automated system to perform its operations. But the kind of use cases we need for next generation robotics to be applied to are much less constrained. I'll give you an example. A fruit picking robot. So it has to traverse a field or a polytunnel and identify and pick fruit. And there's a lot of variation in that system, as you can imagine. The height of the fruit, the location of it, how ripe it is on one side or the other side. It's a more complex inspection and manipulation task. This form of robotics relies really on AI, and that's the real game changer. These modular autonomous systems that allow us to combine conventional control systems in a way with artificial intelligence that allows us to do these complex tasks. Next generation robotics can help a number of the SDGs, including clean water, clean energy, reducing world hunger. An example in the clean water area is of a system I'm aware of that is deployed in remote environments, and it's designed to give clean water to communities. It's connected, it uses AI, and it monitors its performance, and it calls for help when necessary. Yeah, for reducing hunger, so there's a big push on alternative proteins, so replacing animal proteins with more efficient plant-based proteins. I'm aware of some organizations who are using AI to design and identify the kind of proteins that would have the same nutritional and taste properties as the animal equivalent, for example. So on the energy use side, there are many examples. One would be more intelligent building management systems. So the competing goals of trying to have better air quality in the rooms in a building and reducing energy can be worked out with autonomous AI systems that effectively are next generation robotics. Other exciting areas include the use of exoskeletons. Millions of potential benefits there. So people with disabilities being able to physically walk, for example, and be at the right eye level is massively beneficial. Reduction of injuries in manual handling tasks or lifting equipment in confined spaces that can save time. There are a whole host of benefits that can come from next generation robotics. There are some risks associated with next generation robotics, and a lot of these revolve around human perception. So there can be a perception of my job is going to be replaced by an autonomous system, for example. Or if you look at some articles about robotics, they tend to be very polarized, ranging from next generation robotics are completely useless and a waste of money, all the way through to next generation robotics are going to destroy the world and take over humanity. And actually the truth is obviously somewhere in between those two extremes, and when robotics are applied to the right use cases, they are of value. Often early versions of next generation robotic systems can be less functional than the human equivalent. And that's because we iteratively build upon what the previous version is like. So they get faster with time, they get better quality with time. An example might be a fruit picking robot. Yes, it can work 24 hours a day. It can accurately recognize a ripe fruit and pick it, but it might take 5 or 10 minutes to pick a single fruit. And when somebody sees that, they might think that's not a good value solution. And another risk would be, I guess, cybersecurity. If we have a plethora of connected machines all performing an autonomous task, then if there was some kind of cyber attack, perhaps that the performance or what those systems are doing could be altered in a way that's malicious, perhaps. Governments and some organisations do have a role to play in making this technology more accessible and to organisations. So, for example, I mean, there's a huge funding burden sometimes required for next generation robotics development. To overcome this barrier, governments can offer grants, for example, in certain areas to promote certain technology development. Some organisations can offer prizes, competitions for the sake of development purely that could be then applied to other applications. And also organisations can collaborate. If a set of organisations have a similar challenge, then why not put your heads together and try and solve it together? Yes, so governments and organisations can promote training of their staff and workforce. So some of the roles that exist now will change when autonomous and next generation systems are deployed. So being able to work with that technology will require some differences and training, and that's a great opportunity to upskill and retrain people. Right now, there are lots of startup companies who are all working on developing some form of alternative protein that has a similar texture profile or taste profile to an animal equivalent, and they're all facing similar set of challenges. Some of these challenges can be resolved with next generation robotics. I think these companies should collaborate and solve these problems together. Next generation robotics are intelligent machines that can solve problems in unconstrained environments that today are considered impossible to be solved by machines. And going forward over the next 5 to 10 years, we'll see far more applications of this exciting technology, which will be of benefit to humanity.